Welcome back to our third of 6 sessions, Becoming a Microsoft Azure Administrator. And as Alyssa mentioned, today's session is all about Azure Platform as a Service. I'm going to be teaching, in fact, let me start my timer right now for 70 minutes. Now, I don't know if you knew that these sessions are 90 minutes. Totally understand if you can't stay for the whole 90 minutes. There's my Twitter handle down below on this slide, Tech Trainer Tim. I will post, as I usually do, the YouTube links. Eventually, these sessions are all going to be in our library in front of the paywall. But normally within a day or so, the recording is in YouTube. So you won't miss anything unless you want to. Our agenda for the next 70 minutes is looking specifically at the hallmark platform as a service product in Azure, at least as far as I'm personally concerned. That's Azure App Service. We'll use that as a springboard, planning, deploying, and maintaining, and contrasting it with what we've learned in the course thus far. Remember, in last week's session, we examined virtual machines running in the infrastructure as a service scenario. I also want to cover the data platform a bit. That's another whole ecosystem, differentiating the major database platforms, because nowadays the standard is more of a web application as opposed to a static website, and you need something on the data tier, so hence Azure hosted databases. And then a bit on the so-called serverless phenomenon, Azure function apps, maybe automation accounts, whatever. I'm here for you, and after the 70 minutes, as usual, we'll turn it over to you for Q&A. So make sure as I'm teaching, anything comes to mind, send it our way, all right? Looking at the entire seminar series, we started originally with shifting your paradigm, just a general introduction. I kind of had in my head somebody who's coming into Azure from a local IT environment, but I realize now that you may be coming into IT from an entirely different industry, so you're starting directly with the cloud. Either way, your paradigm's got to shift, it seems to me. Last week and this week, as we've already mentioned, it's IaaS and Platform as a Service, PaaS. Next week is a nice synthesis, really, because Azure DevOps is going to involve both infrastructure as a service and platform as a service. And I would dare say that even if you've got experience in a public cloud, you've got another paradigm shift in terms of embracing a DevOps methodology and a DevOps mentality. Infrastructure as code, build and release pipelines, all of this kind of stuff. And lastly, the sessions 5 and 6 deal with practical skill development. First, theory and practice, as I call it, and lastly, certification. I've also noticed that a lot of questions over the previous 2 sessions have centered on certification, so I haven't forgotten that. And I'll make sure to continue to sprinkle tips, tricks, and proven practices in that regard as we go on. Recall also that the session materials are in one of my GitHub repositories. timw.info/admin is the short URI. And just in case you're joining this session for the first time, that will take you to github.com/TimothyWarner/admin. I'll dial it up right here. And we've got in there, let's see, PDFs of each previous session. There's session 1. Where is the session 2 PDF? I'm not seeing it yet for some reason. Well, I'll take care of it after this session for sure. In fact, I'll update it to make sure that you have the final slide deck for session 2 as well. Lately I've been, oh, there's session 2, I'm sorry. So I'll add session 3 after we finish today. Lately I've been a little resistant to share my source in terms of my PowerPoint, so I share PDFs instead. And then as a result of what we talk about and what we discuss today, dollars to donuts, I'll create a markdown file that contains useful links and resources to save you hunting around through the video. I think this also came from last week as well. I've given you a Visio file that shows this classroom reference diagram, has a whole bunch of moving parts. I'm sure we'll refer to that today as well, and you're welcome to use that in for your own purposes. If you're not into Git version control yet, you better be, especially for next week when we do Azure DevOps. But you can download the entire repository as a zip archive here by opening the clone or download button and just using the download zip right here in this dialog box. Awesome sauce. Looks like we're ready to embrace platform as a service, starting with Azure App Service. Now, why did I choose Azure App Service when there's actually many hosted services in Azure? I think it's because, I guess I'm just relying on my own industry experience. I mentioned that IaaS tends to be a natural fit for a systems administrator who's worked in a data center, or just whatever your server class might serve as your data center. Because VMs are natural and it's appropriate, you might think, to just consider running your workload in virtual machines in Azure. App Service, we're talking about hosted web applications. And I think way back, the first websites that I hosted myself, I'm not talking about GeoCities. Speaking of which, I understand that the entire GeoCities archive is available for open source download, but that's another story for another time. You've got a line of business application or a professional website or web application, and you don't want to use GoDaddy or some other consumer provider. You instead want to see what Azure has to offer. App Service is the name of that product family. First of all, what kind of applications can you run in Azure App Service? Well, web applications. You can do static apps like, just straight up HTML pages and CSS files, etc. But we're talking about web applications where you're using a server-side framework. It could be .NET Core, or it could be Java or Node.js. Nowadays, under Satya Nadella, the new Microsoft means that we've got first-party support for non-Microsoft development stacks, which really, I've been a Microsoft specialist for over 20 years. I still shake my head at wonderment that that's the case, and it certainly is. So web applications that go far beyond .NET. API apps is a possibility. An API, or an application programming interface, is a method to access your application rather than how a human would, coming in and clicking and typing. You're programmatically doing create, read, update, and delete operations against the application. Nowadays, we do it almost always, it seems to me, using HTTP or HTTPS. That's called the REST API. And yeah, you can host API definitions in Azure App Service, but, and I'll make sure to include this in my demo, we've got another platform as a service product in Azure called, appropriately enough, the API Management Service, that is a full-scale hosted environment for your APIs. As a matter of fact, just so I don't forget, let me dial up a couple browser tabs into the Azure portal. And on my first one, I guess I'll pause here, and then in the other one, I'll open up again an instance of the portal, but I'll specifically dial up the API Management Services blade. Tell you what, I'll go to App Services in my first blade and API in the other one, just so I don't forget. Web app for containers, what's this? This is where you're looking at the best of both worlds. If you don't know about Docker containers, how could I best describe this? Might be best actually to use my good old drawing tools. Here's the idea. Instead of running your application on a virtual machine, which is going to take a fair amount of overhead, isn't it? Let's face it, regardless of whether you're running the VM in a cloud or on premises, you've got the entire stack from environment variables to backing up and securing the VM. I mean, it can be a mess, can it? A more agile way to do software development is to take just the application, say SQL Server Database, the application and its dependencies, and running it in its own sandbox. Let's just put it that way. Docker is simply, seems to be the de facto container format, but it relies upon Linux technologies that have been around for a long time. Why did developers like these containers so much? Well, check this out. The way you create a Docker container is you create what's called a Docker file, essentially a plain text script file, where you've got your binaries and your source, and then you run using the Docker toolset, this Docker file, to compile an image. And that's the deployable unit. And you may have images for different versions of SQL Server. Maybe your developers are supporting MySQL. Maybe it's an open source project, and your developer wants to easily test using different versions of the MySQL database. You can have an image definition for each of those versions, and then within seconds, the idea is that you can spin up these containers. So it's an agile, flexible way to do development. And then there's businesses, Pluralsight included, that offer production services and containers. So all that having been said, you can take this agility, flexibility, and speed of the Docker container and run the container using the app service as kind of a shell around it. So you've got high agility in your app container, and then all of the bells and whistles, for lack of a technical term, with Azure App Service. And I'm going to demo all that momentarily. Things like auto scale, things like automatic backups. App Service brings a lot of convenience to the table for sure. So you've got that. It's called Web App for Containers. And then you've got two members of the serverless computing family. They're formerly part of the App Service product family. Function apps is where you can upload a code file. It could be a C# class, it could be a Java file, a JavaScript file, even PowerShell. And you set it in Azure and then configure a trigger that will trip the code to run. This is in keeping with, again, modern development, where we're gradually, slowly moving away from a monolithic architecture where your apps are just even if you've got multiple VMs, you've got them stacked into tiers. As opposed to that, microservices is the other extreme, where your code is maybe decomposed to the function level with just a code block. And you're able to just set whatever kind of event that you want to trip off that function. We'll get more into that later because we have some more time than usual to stretch out. So function apps are appealing to developers who are into contemporary programming. And logic apps are the same idea. They're trigger-based, but they actually have a fundamentally different use case in terms of a logic app allows you to build a business workflow that connects different software as a service products together without you having to understand the underlying API plumbing. More will be revealed. As you can see, I'm pretty excited about this. I'm borrowing a diagram from the Azure Architecture Center on this slide, and you can see the attribution URI in the lower left corner. And this is showing how easy, quote unquote, it is to do or host an application in Azure and make it geo-available in more than one region in the world. Why would you do that? Well, you could do it as kind of a standby thing where you're using the primary region for all of your traffic under normal circumstances. But then if the primary region has a failure, or if your application itself has a problem, you can transparently fail over to another region. Another thing, more common perhaps, is an active-active situation where you've deployed your app service to multiple regions of the world, and you're using some kind of Azure load balancing solution to distribute that traffic according to your business rules. For example, in Azure, there's a DNS-based load balancer called Traffic Manager, and you can do things like, depending upon the latency of the client connection into Traffic Manager, the client connection will be distributed to one or the other region. You can do Traffic Manager routing rules based on geolocation. If you have data sovereignty requirements, that connections from the APAC region, they have to go here. If you're in Europe, you have to go here, this kind of stuff. These kind of business logic, you can fit that in a almost turnkey way. I'm trying to avoid slang lately. That's been a little personal initiative. But yeah, without having to know necessarily all of the underlying plumbing, these platform services abstract all that infrastructure. I think of trying to do this, making a line of business application available in multiple points of presence, even 2 regions of the world. How big of a business would you have to be able to support that? Oh my gosh, it's kind of scary to think about. With platform as a service, you can look at it in a completely different way. Hence why I keep harping on that concept of the paradigm shift, that looking at your application delivery and your service delivery in a public cloud like Azure allows you to just greenfield it. In other words, you don't have to reference too much how you're architected the infrastructure on-prem. You've got the world at your fingertips, literally, in Azure. So again, to dive in a little bit deeper, what do we have here? It looks like this application's got a web front end running an app service, and we've got some decomposition. We've got a function app. Maybe a message comes in, or a message is generated in the app, and that gets placed onto a storage queue in an Azure storage account. That event may in fact trigger a function app, and then the code that you've got in there will run. I mean, it's just how you architect these parts and pieces. It reminds me in a way of connecting Tinker Toys, if you remember those. I'm probably showing my age saying that. Or Lego bricks. It really is largely about understanding which service does what and how you can most efficiently patch them together to accomplish your needs. Of course, there's your business requirements, what you need it to do. And there's also stuff like performance, of course. There you've got the full suite of monitoring tools in Azure. You've got security, and there's help available for that with Azure Security Center. There's Azure Sentinel nowadays. A lot of these products, like the Azure Data Platform products, those are PaaS, Platform as a Service products. They have advanced threat analytics built into them. I mean, when you think again about the signal logic that Azure has in terms of all of its hosted services with all of its customers around the world, think of that ginormous data set. And then think how cool it is that Microsoft takes all of that data and trains machine learning models to be able to make accurate and granular predictions about, hey, heads up, we're seeing some suspicious traffic here on your Azure SQL database. You might want to do X, Y, and Z. I mean, that is a super huge value proposition, it seems to me, compared to the old days, or maybe current days, of running local databases on-prem. It's up to you and your colleagues to figure this stuff out, isn't it, right? So this is meant to just kind of serve as an appetizer to get us into the world of platform as a service. Specifically, it looks like we're load balancing these two app services using Azure Front Door. Now, I had mentioned Traffic Manager a moment ago. Front Door is a newer product. I like to describe it as an abstraction layer on top of a whole bunch of other Azure services. So I think Front Door would be a best fit for a business that doesn't currently have the expertise to set up all of the parts and pieces separately, like Traffic Manager would be one. Application Gateway is another load balancer that works with web workloads that you might use in a pattern like you're seeing. The Azure CDN, or the Content Delivery Network, that's another Azure product that allows you to serve static content with minimal latency all around the world. You can just put your static content into, say, the blob service of a storage account, and then put what's called an Azure CDN profile in front of that blob service, and away you go, you see. But Front Door abstracts a lot of that. It allows you, again, I'm using that metaphor, turnkey, to be able to take your application and put it in a fault-tolerant, highly available, multi-region topology without having to have a whole lot of extra specific Azure networking knowledge. Ugh, where to start with a demo after all that, right? Well, let's start at the beginning. We'll proceed until the end, and then we'll stop, if you don't mind the Alice in Wonderland reference. What we're looking at here, I'm in my Azure portal, and I have one app service running, as you can see, and one function app that's running. That's fine. And we can see over here in the metadata, there's something called an app service plan. What the heck does that mean? Well, let's go into this app that I've got here, TW Node App 1, and let's try to figure it out together. First of all, if we come down under settings, we've got scale up and scale out. Notice it says app service plan in parentheses. A platform service is going to need to get its compute from somewhere. Are we agreed on that? With a virtual machine, it's pretty straightforward. You're going to SSH or RDP into it, and you're going to configure that whole dadgum thing, including your line of business applications. When you're using app service, the idea is that you want to focus more granularly on your application and the value that the application is going to offer your customers. So Microsoft abstracts away in that shared responsibility model we looked at in session 1. They're going to abstract away most of the underlying compute, but it's still there. And your app service plan, it's actually a separate resource. If you do a search in the Azure portal, the app service plans are separate, but you need one to host your app service in. And as you can see here under Scale Up App Service Plan, they come in different tiers. There's the dev test level, including a free tier. You never want to use these for business because you're sharing, you're your app service is going to be potentially on the same virtual machine as other Azure customers, and that's no isolation at all, or minimal isolation. So I always recommend start at S1, the standard 1 tier, and the production variety. And as you see here, let me use S1, S2, S3. The underlying virtual machine gets more memory, and the compute equivalent, it tells you what series of virtual machine is the equivalent, and then it gives you an estimated, depending upon where your region is, it'll show in your currency per month what it's going to cost. Now, whereas with VMs, you can turn them off and deallocate them to stop billing on the VM, the app service is always charging, even if you stop the app service. And you can do that from the overview page. If you're having a problem or if you need to troubleshoot or something, you can stop serving the web application, but you're still going to be charged. That's just how it works. So the goal is to choose an app service plan that gives you adequate performance. The other thing that the app service plans give you are features. You need at least the S1 level to be able to use your own business domain, to upload your SSL TLS certificate, to do auto scale, that's a big deal right there. To do deployment slots, daily backups, I don't need to read. To use Traffic Manager, actually, you need to be at least at the S1 level. Now, the thing to remember about app service is that your web application is always going to be accessible on the internet. That's part of being part of a public cloud. On the overview page here, we see that the app is called, I named it TW Node App 1, but then it's at twnodeapp1.azurewebsites.net. And if I click Browse, it'll go out to the content of the page. But this is, in fact, an internet accessible URL. So you need to decide in your source code, are you supporting anonymous connections, or if not? And it's up to you, shared responsibility model again, to add the authentication and authorization controls into your application. Now, what about a business that says, we really like all of the features of app service? You know, it integrates with Azure DevOps just right. We've got application insights for monitoring and telemetry. Automated backups is a win. The ability to create a managed service identity is a win. But the Achilles heel is we simply need to make sure that our app service has no internet connectivity. Am I out of luck is the question. The answer is no, with a caveat. No, you're not out of luck. You can deploy an app service that's completely air-gapped from the internet, but it's going to cost you, which I guess you'd expect, wouldn't you? So if we come back to Scale Up App Service Plan, if we go to the isolated tier, you create what's called an app service environment. These are extraordinarily expensive. Why? Because Microsoft reserves hardware for you. And of course, there's going to be a premium to when Microsoft is actually setting aside physical hardware in your regional data center or data centers for your workload. And so you'll create a special kind of app service plan that runs on the I pricing tier, I for isolated, and you'll embed the app service plan on a virtual network. And a virtual network in Azure, let me go back to my diagram, recall, is a hard isolation and communication boundary in the Azure cloud. And by placing your isolated app service plan in the VNet, you're completely screening it from internet access by default. And you're able to take advantage of all of the controls that are available inside a virtual network. Things like Azure Firewall, service endpoints, private link, all of those bells and whistles are available to you. How would you connect to the app service plan in your app service? Well, you need to have a path somehow or another. You'd be doing site-to-site VPN or express route, or you might use Bastion host to come into a VM on the VNet and then interact with the app service. I mean, that's up to you, but that's possible. It's part of the platform as a service that's in app service in general. How do you get started with app service? I'm showing you an app that's already here. What would a developer need to do if you wanted to take your existing app that you're developing on your local computer and put it into Azure? I had mentioned that it's not a .NET world anymore with Microsoft, and that's certainly true. If you do a search for Azure SDKs and tools, that's normally what I search for. we can come to the appropriate page at the azure.com site where we've got software development kits, it seems, for Java, Python, .NET, JavaScript, and then under standalone tools, some others. So, you know, you would make sure to, whatever your development environment is, that you've got the SDK installed. Now, what I'm going to do here, let me go to my other browser and get a URL for us to use. My good friend Mike Pfeiffer has a Node app that he kindly gave me permission to use for this purpose that we'll use as an example right now. So he's got this hosted in a public GitHub repository. It's a Node.js web application. It's got a built-in collection of unit tests. It's a finished web app, which I thought is a good idea for our use case. And let's say we want this to run in our Azure subscription. What would be some ways that we could do that? Well, I'm on Windows 10, so naturally, I guess you might think I'm going to use either Visual Studio or Visual Studio Code. I'm actually going to use Visual Studio Code, which, if you don't know, is a free cross-platform open source code editor. It's fantastic. And because it's got an extension model here, you can load in support for whatever development language or framework you're programming against. What I've done is that I searched the extension gallery for App Service, and I simply installed the Azure App Service extension, no problem. If this is a Node app, I might want to look for Node-specific extension helps here as well, but I don't, strictly speaking, need to. I have Git already installed on the system, and if you don't know what Git is pretty much the de facto source code version control software nowadays. And if you have Git installed on your machine, it'll function transparently with Visual Studio Code, so our bases are covered with that. To that point, I can open up the command palette and just simply type what I want to do. Git clone. I want to download Mike Pfeiffer's repository from GitHub. I have his clone URL in my clipboard, I think, maybe not. Let me go back and open up clone or download, and I'm going to copy his clone URL to my clipboard and paste it here into VS Code, and it asks, where do you want to download the project? I'll use my desktop, that's fine. And now it says, do you want to open the cloned repository? Yes, I do. Now, VS Code has a full debug environment, etc. We're not going to get down to that level of detail. We don't need to. It's not that big of a deal. I'm just trying to get to the high-level points here. So you're working in your local development environment, and I've got, I think, everything I need here to upload this project and get it running in Azure App Service. I've installed the App Service extension just to cover my bases, especially if you're an administrator. I hope you have PowerShell installed on your system. If you're using Mac or Linux, you can install PowerShell 7. This is Windows 10, so PowerShell is already there. You'll just want to install the PowerShell extension to light up PowerShell language support in Visual Studio Code. That's always good to have. And if I open up a terminal session, you'll also want to make sure, this is a good tip and trick if you're an administrator, is to install the Azure PowerShell modules on your system as well. And if you're on Windows, you've got direct access in your PowerShell console to the PowerShell gallery. So you can do something like install module AZ, and that will pull down all the Azure PowerShell modules. And I think at this point, we really are ready to go. So if my memory serves, we can go to the command palette and start to type App Service. Yeah. The extension model, when you load up an extension, it normally has a whole collection of context-specific commands, as you can see here. And so the Azure App Service command, what do we want to do here? We want to create new web app. So I'm going to select that. Select subscriptions. Now this assumes that we've been authenticated into Azure. I forgot to mention that, sorry about that. There's one more extension you might want to load up. It's called the Azure, is it called Azure Sign-In? Azure Account, yeah. The Azure Account extension is really cool because you can authenticate into your subscription and VS Code will maintain your authentication state. And so because I've already authenticated as an owner into my subscription, I can then use the App Service extension to choose first my subscription, as you see here, click OK. Now it's saying, what do you want to call the app? It needs to have a globally unique name because the app service is going to be on the Azure Websites.net DNS zone. So I'm going to call this PS Seminar 001. Hopefully that's globally unique. Press enter to confirm. Select a runtime. Now, the extension was smart enough to see that our app service plan is going to be Linux rather than Windows. Now, could it be Windows? Yes. This is a Windows, and I have Node installed on this box. But this extension is assuming what we're going to do a little bit. You notice that a little bit earlier, there was an option in the app service extension to do an advanced deployment. That would give us more choice. But I'm just going about it this particular path. What do I want to choose? I don't remember what Node version Mike has specified. I'm going to roll the dice and go with Node 10 long-term support. And then, is that all it needed? Notice that it's not giving us a lot of additional choices. Again, it's a trade-off situation, really. I mean, this is just one of n number of ways that we can get an application that we're locally developing into Azure. We could always open up the output window and see if we're getting any feedback. Oh, there we go. It looks like in the lower right corner, it's creating the app service plan and it's naming it for us. Now, as an administrator, you may be thinking, I mean, it's easy to do what we've just been doing. It's now deploying the infrastructure in Azure for us. That's cool, but where is it putting it? What region? It really didn't give a lot of guidance, did it? So again, I'm thinking in terms of trade-offs. What are some other ways that we could have done this? Well, we could create the shell of the application or the hosting environment for the app in Azure and then tap into it from our local system. So I just wanted to show a couple patterns here. So for example, we could go back to app services and say, let's add an app service right here, right now. And in this case, we're able to specify everything. I'm going to choose the Pluralsight resource group. Again, it has to be a globally unique name. Hopefully that's, yeah, it is. As I mentioned, nowadays you can do just code with a runtime stack, or you can do a Docker container. And if you choose Docker container, you specify where your image is coming from. That would be the next step. Otherwise, you choose your runtime environment. I'm going to choose, actually it would be Node, as I said. I chose Node 10 LTS. And actually, it looks like in Azure, it's forcing us to use Linux as the underlying app service plan, the compute layer. That's interesting. This, I guess, speaks to so I want to pause here, actually, because this is a good real-world consideration. It's perhaps more of an Azure architecture question. But in some cases, you may want to use an Azure platform as a service product, but you get dead-ended. Maybe your business requirements were that you need the compute for whatever reason to be Windows Server as opposed to Linux. Well, here we see an app service that's not supported for at least Node 10 LTS. Interesting. So that may cause us to go into another direction, maybe even use a virtual machine in Azure and install Node and put the app in it that way, see? So anyway, we'll choose our region in the world. We can reuse an existing service plan, which is one that it looks like VS Code has created, or we can create a new one. As an administrator, again, I want you thinking in terms of monitoring and telemetry. While you can put more than one web app into the same app service plan, you want to think about it because depending upon how powerful or how much compute is in the app service plan, you're going to get degraded performance the more you put and burden that app service plan with. That's, again, more of an architectural question. So you choose your plan, what you want to do. For monitoring, it's good. This is another good pause point. In Azure, for application monitoring, your general purpose go-to is application insights. And I'm not a developer. I've never yet in my career had a full-time development role. But certainly, almost uniformly, every developer in my life has said great things about App Insights in terms of the insight that it gives you into the full-scale behavior of your application. Seems to me that monitoring is particularly important when your app is running in an environment that you don't own and fully control. So App Insights is a separate platform service, as you can see here, and you could just use an existing instance of App Insights and reuse it with multiple applications, or you can create a new instance. It's up to you on your need for data isolation. Taxonomic tags in Azure are a great way to identify resources, principally for cost center and organizational purposes. In fact, a common tag name is cost center or something like it. I might call this cost center Pluralsight. And part of the way Azure Cost Management Monitoring works is you can create your cost reports and your forecasts and plot that data on the basis of tags. So tags actually are very important indeed in the Azure ecosystem. So there you have it. Once this deployment finishes, we'll then have an empty app service that we can then populate with code. While this deployment is cooking along, we can review the input properties that or the arguments, for lack of a better term, that we added when we deployed. If the template has any outputs, they'll show. And then speaking of which, we have the actual structure or the definition of the deployment. Remember that in Azure Resource Manager, every single deployment takes place in the context of a resource group, and every resource is defined in JavaScript object notation and validated against an ARM schema. And Microsoft keeps all of their Azure Resource Manager schema definitions in, where else? Wait for it, GitHub. What else do I want to say here? Let's check on the, okay, it's finished. So let's go to the resource, and here's that new app service. It's empty. If we browse the site, it's just showing us a plain old garden variety placeholder page. But we can fix that very easily. If we come down under deployment, we've got deployment slots and deployment center. What's the difference? Why do you care about one or the other? Well, deployment slots are cool for staged application delivery. Imagine it this way. Your application and app service always has the production slot, and that's what's facing the public. You may want your developers, or your developers may want to, work on another instance of the application, maybe with a separate connection string to a separate database, but it's in Azure yet, so they can test it in the environment where it'll actually be running. Well, that's what a deployment slot is. So we can add a slot here. I'll give it a name. I'll call it dev. And if I can type, that is. And then you can optionally clone the settings from another slot. In this case, I just have the production slot. You can either clone them or not. And I'll have more to say about that in just a second. Now, the thing to remember from an administrator's point of view and from a resource consumption point of view, from a cost point of view, is that when you use deployment slots, you're instructing Azure to duplicate the entire application in another VM in your app service plan. So I've had people I've worked with in the past say, I have just a basic web application, but the performance is just terrible. And we see that they've maxed out their deployment slots. It's like, oh, I forgot I did that. Don't. These are separate instances of the app that are consuming compute in your underlying app service plan. So again, as opposed to where you would normally, I guess, in a local application, store your application settings and connection strings in config files, those can be dangerous. You never want to commit sensitive secrets into source code, for instance. Here in Azure and App Service, in a hosted environment, the pattern is you can store that sensitive data securely in your app settings, which, as you see right here once it loads on the configuration blade. Hello. We'll be able to specify key value pairs. We'll be able to do connection strings into databases. There we go. Yeah, so looks like we've got some these are just created by Azure, evidently. And then we've got our connection strings. Now, what I want you to see here is this property deployment slot setting. The way that works is as follows. Let's say that we're working on the production slot, which is where we are right now. We can verify that because it shows just the name of the application. We would define a connection string that points to our production database, agreed? SQL Server, whatever it is. And that data, when you, I didn't mean to do that. That data, when it's added, is actually hidden in Azure. You can expose it if you want to, but it's stored as a secret. And that's a good thing. However, if you're doing, Let me get back to where I wanted to. Configuration. If you're doing deployment slots, you're going to have a different connection string in all likelihood for your production and your development databases. You may have application settings that are different per environment. When it comes time to do a deployment slot swap, say that 3 times quickly, by the way, you're taking the one, say your development slot, and you're switching places with the production. A great way to do staged, fast application delivery. You can make sure that those kind of slot-specific settings stay put just by ticking a box for deployment slot settings. So that's what I was trying to say with that. That when you're using slots, you've got an entirely different set of metadata. And the way you switch between them in the portal anyway is you go to deployment slots, you hit the slot that you want to go to, and the URL is actually different. Instead of webapp.azurewebsites.net, the URL is webapp-slotname.azurewebsites.net. Aha. And as I said, all of your configuration settings, unless you specifically say it's a deployment slot setting, will swap when you perform a deployment slot swap. Another advantage of platform as a service here is that you can, on the fly, change your stack, change your stack version. There's a lot of other built-in properties here. So although you're not getting full access to the underlying VM, the development team at Microsoft is trying to expose the most common and essential properties and surfaces them here. You can actually get a console in App Service if you need to. If you do a search, I guess it's not under the setting called console. What is it under? Let's see. SSH, I guess it is. For Windows, I think it's called console. But you do get some visibility into the underlying VM that you're on. You're not going to be able to do all that much. You can sanity check the file system, but eventually I'm going to get a prompt here, hopefully, and you get some level of terminal access. Oh, it looks like we've got an error down here. I'm not sure what that issue is, but I'm just trying to walk through this with you here, some of the elements of platform as a service and some of the trade-offs, frankly, that you see. Because this is a Linux VM, some of the options are grayed out. Some things are available when you're doing Linux app service versus Windows. Some options are lit up or turned off if you're doing the container option. So depending on specifically what you're doing, you're going to see different options light up or not. So again, that's something that A, means that you're always learning. That's been a theme throughout this seminar series, hasn't it? That you need to be a perpetual student and know what's available. And also, I dare say, keep your ear to the ground on updates. I'll have more to say about that in our last couple sessions of the seminar. Because Azure's always changing, you should know where to go to be apprised of feature changes and updates as they happen. Okay? All right, cool. Well, again, let's come back to the initial question was, we're looking at different ways to deploy our application into Azure App Service and get rolling with it. And the first one I had shown was in Visual Studio VS Code, where we used an extension. It says create a new web app PS Seminar 001. It's all ready to rock and roll here. Well, why does this say deploy? I'm not sure, to be honest with you. Maybe there was more to that. I don't know. Moving on. Nothing to see here. And the second thing I did is we created an empty app service in the portal, and that we saw gave us much more flexibility in terms of properties. Now, if you're already an advanced user, you might be sitting there scoffing, saying, well, what about automating this whole dadgum thing? And you're absolutely right about that. If I go back to Mike Pfeiffer's original repository, I think it's this one. Yeah. He actually has an Azure template in there, an Azure deploy.json. This is something that we could have deployed initially via code using, say, Azure PowerShell. We can just send this template up into Azure, and Azure will follow all of its instructions. And all this particular ARM template does, looks like it has a couple parameters. the host portion of the web app URL, right? That makes sense. The name that you want to give your service plan. And then once you get down to the body of the template, it's defining the actual resources. And specifically, this will create an app service plan, and it'll create a Linux-based web app. Infrastructure is code, absolutely. Ultimately, I'm hoping that you'll be looking at this as your mainline way to deploy infrastructure, as opposed to horsing around in another tool like the portal, or even an IDE isn't strictly speaking necessary. Just different ways to accomplish that. But in this empty shell of an app, first of all, let me make sure, I want to go back to my production slot. One hazard I've found that when you're working with app service and you're working with slots, you really have to keep your eyes peeled. You have to make sure that you know which edition or which instance of the application you're working with, because you may in fact be working on another slot when you wanted to be working, say, on the production slot. Yeah. My brain is a little bit fried right now. Please excuse some occasional clumsiness here. I think it's, I'll leave it at that. Yeah, okay. So when all else fails, just come back to the original blade. So I know I'm at the production slot now because I can see that echoed on the overview page. So under deployment slots, there's deployment center. And this finally gets to my original point about how to actually populate this empty app service with code. Long story short here, this one, it looks like it's mapped. I'm going to disconnect this and start over. Yeah, you choose your source code provider, and you can come from just about anywhere nowadays. If your code is already in Azure DevOps and Azure repos, if it's in GitHub, Bitbucket, or you could just do a local Git repository that's associated just for this app service. That's what I'm going to choose here. And then as far as the build service, Kudu is the one that's built into Azure App Service, or we could integrate with pipelines with a couple mouse clicks. I'm going to choose Kudu and then finish this. And so here, Azure is going to initialize a Git repository for this app. And here's the clone URL. So it's the same pattern. I will clone this empty repository to my system, populate it with code. I'm going to need to add a remote to come back up into Azure, and you can set deployment credentials per user, or you could just create a shared credential set. And then I would push the code up into here, you see. So the idea, and this really goes across most or all of Azure, is that Microsoft wants you to be able to continue to use the tools that you're familiar and comfortable with, and to adapt to they don't want you to have to adapt to a different workflow that you're comfortable with. And that, I think that's pretty cool. How does app service differ from, say, the serverless options like function apps? If I do a search for function app, there we go. The function app is where you're doing code as a service. The function app is basically a container into which you populate one or more functions. And the process of creating a function here is going to be, first of all, choosing what kind of trigger. Actually, the function app is where you decide what your runtime environment is, and I probably should have just created a function app to show you this. Yeah, let me just do that. Let's say that we have need to include, say, email functionality in our app service. We've got an app service, and we want to decompose the ability to take, say, the results of a form that a user is signing up for, and we want to process and send them an email. And we don't want that in our monolithic app code. We want to decompose it. We could just do that in a single file, code file, that we host in Azure, and then whenever the appropriate event happens, whatever that is, the code runs. It's literally that easy. So the app is the container, and as you're going to see in just a moment, it shares a lot of similarities with the app service itself. I'll call this function app 00001. It has to be globally unique. Somebody called it that, it figures. How about if I call it PS function app 0001? That can be a pain in the neck. And yes, we're not going to have time to get to it today, but you can and should associate your business DNS domain with your app service so you can use your own URL paths. We can do Docker or code, same song and dance as we saw before. Choose a region. I historically choose East US 2. The hosting for your function app uses the same thing as app service. You potentially can use the app service plan. You also do have to have a storage account. That's to store your code file and any other artifacts that you need to run as a dependency. You can do Linux or Windows, and it's a little bit different from web apps here. With function apps, you can, as I said, do an app service plan that uses the same pricing model. You can even share an app service plan between a function app and a web app, let's say. But function apps are a little bit different. There's a consumption option where the underlying VM, it just sleeps, for lack of a better term, and then when the event trigger happens, the VM has to start. That's called a cold start problem because that latency ticks off a lot of developers, I know. So consumption has an advantage in that it's got a very generous free tier, but the downside is, like I said, that cold start problem. It takes a while for the function to actually start working. So you can get predictable performance with the app service plan, or you can do, there's actually a premium plan, which I think is always hot and always predictable performance. And I think it also, my memory serves, the premium, the price differs on how many executions you do per month. You'd have to look at the pricing details. It's not particularly important for our purpose now. I'm going to set this to consumption and then go to monitoring. Once again, the monitoring here for your app service apps is in application insights, and you've got your tags, and then you create it. Okay, so that's the app. Once you have the app, you then populate the app with one or more functions that all use the same runtime and underlying compute layer. So it's kind of a family of functions. This O'Reilly Func App 1, I don't know what my runtime is. You can check all of those settings here in the Azure portal. But to get to the heart of the matter, because I want to keep my eye on the clock as well, you choose which trigger. You can use as a trigger something as simple as a webhook or an HTTP notification. Or if you want your function app to work on a, there's Alexa. Bye, Alexa. You could do a timer trigger to have the function go off on a schedule. And then there's a whole bunch of pre-built integrations with various Azure services. So let's say, for instance, your web application has the ability for your customers to upload a file. You could use the creation of a blob in your storage account blob service as a triggering event to run your function. You see, literally, it's just your imagination is the only limit here. So you choose your function, you choose your trigger, and ultimately you're taken into your code, your source code. And if you're a developer and you're already up to speed with an object-oriented language like C# or Java, that's good. But if you're an administrator, which is what this whole program is about, functions, well, there is the PowerShell environment. That's true. That we do now have support for PowerShell and functions. So perhaps functions are a bit more administrator-friendly than they used to be. But what I normally recommend for an administrator who may not know a development language but is comfortable with PowerShell or maybe even Python, you can take advantage of the automation account. The automation account, as you see, is a separate Azure resource. It has a whole bunch of functionality built into it. It's actually, gosh, it's almost, you could look at it as an administrative Swiss Army knife. If you're an IT administrator, you might want to dive into automation to a greater degree of depth because there's a lot here. There's inventory tracking, change tracking, there's desired state configuration for configuration management update. I mean, there's a lot. But specifically, what I was thinking of as an analog to running code on demand or code as a service is what's called the runbook. And all a runbook is a hosted PowerShell script or a PowerShell workflow or even a Python script. There's a whole gallery of community submitted runbooks that you can choose from and use as your base. There's a basic debugging environment. It's nothing too special, but it provides a convenient way to do whatever it is that you need to do in code in Azure and automate stuff like being able to authenticate, for instance, not having to do a manual authentication. Some of the most popular runbooks are ones that do things like you can see on the screen here. Look at these most popular ones. Start and stop Azure VMs. There, save yourself money. If you know that you're using your VMs only during your time zone business hours, you don't have to actually remember to shut them down. You could host this as a runbook that runs on a schedule, that every day in your time zone at 5 p.m. or whatever, it will shut down the VMs, and then the next day it'll start them up for you. You see what I mean? Swiss Army knife utility. Really specially good service for IT administrators who are interested in Azure to get to know, as opposed to, say, the Function app. Now, I'd also mention that API service. I just want to jump over there for a second. If you are an application developer, you likely have your app service as a web application. I'll just draw that as a circle with web application. And you may have or may want to do your API definition in that context, but in keeping with more contemporary software development, where the trend anyway is to decompose your application into freestanding parts that you can scale independently, that you can update independently and debug independently without hopefully affecting the rest of your application. Well, that's where API management services comes in. This is a hosted platform for REST API definitions. So you create the service, which I've already done, as you can see here. And again, telemetry is always available in the Azure portal. If not in Azure Monitor, you normally can get to it from the overview blade of the resource. As you can see, capacity, errors, etc. But here's where you can import or define from scratch your application programming interfaces. And in the Azure Docs, there's an excellent step-by-step tutorial. It's called something like Import Your First API into API Management Service. It uses a back-end data source that stores fictional tech conference data. So the API definition is called Demo Conference API, as you can see here. And the value proposition is that you've got a managed platform as a service for hosting and collecting your various APIs and having full control over their lifecycle without having to worry about any of the other infrastructure details. So we've got the design services you can see here. If you want it, we've got an operation for getting a specific session by the session ID. You define your URI paths and your parameters, and you can do things like processing both the request, the HTTP requests, and responses by adding policies. This is pretty darn powerful. The ability, for instance, to do authentication. Maybe your API is not for public consumption, but instead you have to request, or your users would have to request, an API key or authenticate with Azure Active Directory. That's here. The ability to protect your APIs against abuse, doing stuff like rate limiting. All of that stuff is available here. It's really cool. And there's even a test capability here where you can test your API live. So get session here, we can pass in a value for ID. Show me session ID 1. Query parameters, headers, shows you the request URL, the actual HTTP request, and then it sends it out. Looks like 404, session not found. Okay, well, let's try the get sessions operation with no parameters. So that should go back to the data source here at Microsoft and bring back all of the conference sessions. And those results, as you would expect in a REST API context, come back in JSON format. Yeah, there it is. So we've got the various properties here for the different sessions. And my heart kind of pangs because Scott Allen is in here somewhere. Rest in peace, Scott. Last thing about this API thing that I think is cool is that Microsoft actually creates a shell web application that you can get a big head start on documenting your API. And you can modify and keep this in source code, customize it to your heart's content, but it actually contains automatically generated definitions. When you build out your API definition, the developer portal here, as you can see, lists any APIs that you've created. and creates these documentation pages. This could potentially save you a lot of work if you want to offer your customers an API to access your application. That making some semblance of sense? So where do we want to go in our remaining 10 minutes before we open it up to questions and answers? Let me just go behind the curtain with you and take a quick look here. Pros and cons of app service. Let's take a look at this. Some pros of platform as a service and app service in particular are that you can focus more on your code and less on infrastructure. You've got integration not only with Azure pipelines, but with all the other Azure products. You've got little worry about availability or geo-distribution or backup. In many cases, backup is either handled automatically by Microsoft or it's a turnkey solution. App Service has a turnkey where you just turn automatic backup on and let it go from there. Auto scaling, right? I forgot to actually show that. Let me just quickly jump over there. If we go back to app services, this is a huge value proposition of hosted web apps in Azure. Let's say that this TW Node app, we're expecting big traffic spikes next week or next month for whatever reason. And right now we're running S1, which is a modest VM, let's face it. And we want to ensure that as the traffic spikes bigger and bigger and bigger, that our customers and our site visitors receive predictable performance. So one thing we can do is come down to scale out, which also happens in the app service plan context. And we can either manually scale or do a custom auto scale operation. And this instance count here, I can go from 1 to say 2 to 3. Just by moving my mouse and clicking save. Think of doing that with your VM-based web servers. And not only that, think of what else you'd have to do this in Azure or elsewhere with VMs. You'd have a load balancer or an application gateway that you'd have to put in front of those VMs. And then what do you do once the traffic spike goes away? Do you just delete the VMs? Yeah, well, this is pretty crazy how automated this is. If I click save, Azure's going to spawn 2 additional VMs and take care of load balancing for me. It's going to take care of making sure that each VM is configured with the application appropriately. I mean, yeah, so that's manual scale. Manual's not optimal, it seems to me, in general terms, unless you know that you're going to want more than one as a baseline number of VMs behind your app service. When you do custom auto scale rules, the most common pattern I've seen is you create scale rules, a scale out rule and a scale in rule based on a metric. And what that means specifically, normally, is that you'll create the rule based on CPU percentage that's an aggregate across, if you have 2 nodes there as your minimum, it would be an average of CPU across the entire server farm. And you specify what the threshold is. If it's, for instance, greater than 70% CPU utilization over 10 minutes, then increase the instance count by 1. And make sure to wait 5 minutes before you do another scale, just to avoid false positives. And so we can go out to a maximum number of instances, and we would also want to create an auto scale rule that does the opposite, that when the CPU reaches a certain threshold in the downward direction, scale back in to save you money. Nice. And you put your instance limits here. And you can also add additional conditions such that you can pre-schedule the rules to go into effect on a particular date and time. So like I said, if we were going to do a product launch next Monday at 8 a.m. Eastern, we could set up the rules in advance and have them automatically go into effect and then stop when the start date and the end date happen. Really neat convenience, isn't it? But anyway, to come back to the pros and cons, intra-region load balancing, yeah, the fact that when you do auto scaling, the load balancing is all totally automated. And then if you want to make your app service available in multiple regions, you simply deploy the app service to another region. It would need to be in another app service plan because the app service plans are region specific. But then you would put those app service nodes or those endpoints behind, say, an application gateway or a traffic manager profile or a front door, you see. Now, what about the cons? As I mentioned earlier, not all frameworks are supported. There's quite a few to choose from, but if you're not in the supported list, you're going to probably have to go to a VM. You also surrender full access. That's the biggest trade-off. You're giving up full access to the underlying compute. And as I said, that when the web apps are stopped, they still incur cost. But by and large, it's not too bad, is it? Not too bad. Let's see, relational database options here. Don't need to spend too much time on this, but the pattern that I want you to see is that Azure gives you first-class support beyond Microsoft's own SQL Server. We've got Azure SQL Database. In fact, fun fact, Azure SQL Database was the first product in Azure when it was called Windows Azure. The product wasn't called Azure SQL Database. I actually forgot what it's called, but let me know in the Q&A if you happen to know. And the idea with Azure SQL is nowadays the SQL Server teams, when they do new feature development, they put it into the cloud first, and then, if it's popular enough, they backport it to SQL Server on premises. Some folks don't like the Azure SQL Database because of the fact you don't have full access to the server. Managed instance is like a halfway point where you get much more access to the underlying SQL Server, and you can do things like SQL Server agent, database mal, and features that you don't get with the hosted Azure SQL Database. So managed instance is like between one extreme, Azure SQL Database, and the other extreme, running SQL Server in a VM. Synapse Analytics used to be called Data Warehouse. It's where you're using SQL in a more of an analytics context, when you're using SQL Server databases in a more of an analytics context, where you're using a compute cluster, parallel processing, to be able to do longer running, bigger data set kind of work. And at Ignite 2019, Microsoft rebranded Azure SQL Data Warehouse to Synapse. And the reason for that is that now Synapse goes beyond Azure SQL and can go into Apache Spark and NoSQL big data analytics. First-class support for MySQL. There's Azure Database for MySQL. MariaDB is a fully open source fork of the Oracle MySQL database. Postgres, there's a hosted Azure database for that. And then, of course, any database you want, you can run in a virtual machine. As far as non-relational, the main choice there, the only one really, is Azure Cosmos DB. And this is a multi-model, non-relational hosted database. It offers some really compelling features, in my opinion, like geo-distribution. You can geo-distribute Azure SQL databases as well, but Azure Cosmos can do multi-region writes. It's got 5 different consistency levels. So if you make an update in this region, how long, what's your tolerance for latency before that update shows up on your other Cosmos instances elsewhere in the world. But the 5 APIs or the 5 models correspond to different types of NoSQL non-relational data stores. The main one is core, and that uses JSON documents as the data source, and there's a SQL-like query language that gets attached to that as well that's supposed to be more familiar to people who come from a relational world. Mongo is JSON, Cassandra is wide column, Azure Table is key value, and Gremlin is graph. Those other methods, those other APIs are intended for businesses who are going to take their MongoDB and host it in Cosmos. You can do that without updating your source code because the MongoDB API is compatible with the native MongoDB API. You see what I mean? Same thing with Cassandra and so on and so forth. All right, we're getting dangerously close to Q&A time. Thanks for hanging with us so far for sure. How about your skill development with Platform as a Service? What are some takeaways before we get into it? Well, I don't know if you knew this, but we at Pluralsight are developing cloud labs that will work in both Azure and AWS. These are not simulations. This is the live Azure, live AWS environment. And this is going to close the gap between theory on one hand and hands-on practice on the other. And although the Microsoft certification exams currently don't have the performance-based labs turned on due to the COVID pandemic, eventually I would suppose they will come back. And when you're faced with a performance-based lab, either you know how to do the hands-on work or you don't. So something like these are compelling. Excuse me. Timeline for at least the AWS ones I believe is 2020. In Microsoft Learn, which you can get to in the course files here, I link out to Microsoft Learn. Many of those labs have a sandbox environment where it'll take you into the Azure portal, or it'll give you an Azure command line interface session where you can get hands-on practical skills with Azure Platform as a Service in a live environment. So again, make sure you know about Microsoft Learn. You can't beat the price, it's free. Alrighty, well, at that, I'm going to now ask Alyssa, any questions that I can entertain at this time?
Yeah, we have a few. So first one, can you run Azure as a private cloud?
Yes, you can. The product family is called Azure Stack, and the nutshell elevator pitch with Azure Stack, at least the hub, the main product, is that you either lease or purchase a physical rack, and it's basically a black box. You're not allowed to go inside it. That's part of the abstraction of the cloud. But what's cool is that Azure Stack is effectively Azure in a box. It doesn't have all of the Azure public cloud features, but it has all the core ones. We're talking storage, hyperscale, app service, Azure SQL Database, and you put this server rack in your data center, and you can use all of the Azure software development kits the same, Azure PowerShell, Azure CLI. You can develop and administer the same way you would in the Azure public cloud, but you can do it in a completely air-gapped environment. So yes, you want to look into Azure Stack, in particular Azure Stack Hub. The idea is that you could put an Azure Stack hundreds or thousands of feet underground in a mine shaft and have the power of Azure available to your folks, or in the middle of the sea or in a submarine. Those are kind of extreme examples, but I hope I transmitted the point.
Our next one reads, web app for containers, are they similar to an orchestrator like Kubernetes?
Nice question. No, it isn't. I would say that web app for containers is an alternative to Kubernetes, but it's a different paradigm. On the left here, you've got your app service with all of its bells and whistles, and we optionally can post or start a Docker container from an image in the app service. And yes, then the app service can scale and do some of the things that you might expect on the other side of the fence. If you're using, say, Azure Kubernetes Service, you've got the compute cluster there that consists of Azure VMs, and you can fully orchestrate your VMs, your pods, your groups of VMs, and so on. But no, it's a different paradigm from what you have in App Service. Although you got me thinking, thank you for that question, because I'm going to investigate after class about hybrid possibilities. If it's possible to take an AKS-based pod and get it to work with App Service. That I don't know, but thank you for inspiring my curiosity. I'll jot that down.
Okay, sounds good. And while you're kind of drawing on the screen, what drawing tool are you using?
This drawing tool is called Epic Pen. Yeah,
Okay,
and it's been worth every penny. It really has. I like it a whole lot.
thanks. Next up, how does an IT ops sysadmin transition to PaaS technologies like web apps, APIs, etc.? Is it a company or management decision to move to PaaS, or can IT professionals learn these skills on the job and steer management towards that choice?
Yeah. Yeah, one of the points I made during session one, actually, and I made it kind of tongue-in-cheek, but also at least halfway serious, is that as an Azure administrator, you may very well be the go-to subject matter expert for Azure. And because the Azure toy box is so large, think of the API management service, for instance. Your managers, your development staff may not even know it exists. So if they're thinking of hosting an API in Azure, they may naturally gravitate maybe towards a virtual machine, no, or app service, but then you, because you've gone the extra mile and broadened your skill set, can surface some of these additional possibilities like API management and be really good value to your business. Because ultimately, PaaS is about flexibility and agility, but there's also the cost savings. Your chances are you're going to save a lot more money with PaaS as opposed to doing everything with monolithic VMs.
Our next one kind of refers back to one of your first demos, and it was about 30 minutes in. So what was that PowerShell line? Was it install space module space dash space AZ?
Yeah. If you're on Windows 10, you have the PowerShell get module, which allows you to interact with the PowerShell gallery. And specifically, you can do something like find module just to query the gallery. And the module you want to find if you want to install Azure PowerShell is called AZ. It can be confusing because there's an Azure RM module there's an Azure module, but no, you want the AZ, which is the latest and the greatest. And the specific command I showed was install module AZ. And that will download AZ, which is a bootstrapper. Because actually, the way that PowerShell works in Azure is that the developers decomposed all of the modules. It's not all the commands in a single module. There's like 30 of them for each service. And AZ is a bootstrapper that orchestrates and installs all of the independent modules.
That was super helpful. The next one is, can you share your IaaS dashboard in Azure Start Dashboard?
You mean that picture? Let me see. Well, I shared the actual Visio with you. That's in the exercise files. You know, in the Azure portal, you can either have the home view or you can do the dashboard view. And specifically, if you're wondering what I did here, is I edited the dashboard and I brought out the markdown tile. Markdown, if you don't know, it's a play on words. It's a markup language, but it's meant to be pretty intuitive, I guess, and it's a way to apply rich text formatting to plain text. And all I did in this particular markdown tile, let me close out of here. Whoops. Let me go to edit. Is I simply used the image IMG HTML tag. I put a copy of the Visio file. I made a ping image out of it. I uploaded the image into my web server, and I just did an image tag here and brought it in. That's all I did. But really, it's good for you to know about the markdown tile. I've found working with customers, they really appreciate it because you can use the markdown tile for anything. You could create procedure lists, punch lists of to-do items. I had one customer who did a disaster recovery plan and put it in a markdown tile, and you can have multiple pages of these dashboards, you know, and you can switch among them. You can share dashboards so that your teammates can load them on their system. The dashboard systems Azure is pretty darn cool, actually. Thanks for asking.
Great, thanks, Tim. Our next one wants to know if the CERT test has any hands-on labs that you have to do.
Historically, yes, all of the AZ exams have performance-based labs, but all the experience I've had taking tests over the last couple months and other learners who have reported to me, Microsoft Learning hasn't made an official announcement, but Microsoft Worldwide Learning appears to have disabled the performance-based labs across the board, and my personal opinion of that is to save compute, maybe to save Azure capacity for paying customers. I mean, that's the best thing. I couldn't tell you if I knew it under NDA, but the best I can tell right now and for the time being, those labs are all off, which is a good time for you to certify now, actually, because it's not that the hands-on labs are that difficult. What happens is the exam interface will show on the left side of your screen the Azure portal, and it's actually a live connection to the Azure portal. And then on the right, there's essentially a punch list of tasks that you need to complete, maybe 7 to 9 of them. And there'll be a set of credentials that you'll need to sign into the Azure portal with, and that, of course, is important because that's your student session. And you complete the tasks in any order. They're independent, they're not dependent on each other. And you can use the portal tools just like I've been doing in my demos. Microsoft Learning did tell me directly that you can also use the Azure Cloud Shell if you're more comfortable using Azure PowerShell or the Azure CLI. That's perfectly fine. And it's just the results that get graded. Pro tip about this, if you do get a performance-based test, if you're asked to create something, just create it and click create and make sure that in the notification menu it says creating and it hasn't errored out. You do not need to wait for the deployment to succeed. You don't want to waste time because your timer is going to just run through the entire exam session. It doesn't get paused during the performance-based labs. But to wrap this up, now is a really good time, honestly, for you to certify while the labs are turned off. If for no other reason that you can have those extra minutes that you would have spent on the labs, you can now devote them for the other questions that are on the exams.
Our next guest asks, where can I continue learning how to become an Azure expert? Any certifications that you would require or need?
Well, it depends. If you know right out of the gate that you want to specialize in Azure, that's awesome. I mean, this seminar series is aligned informally with the Azure Administrator certification. So if you just do a search for like Azure role-based certifications, you can take a look at all of their badges, and one of which is for the Azure Administrator. So that would certainly be one thing to look at. If you're brand new to Azure, you might actually want to go for the Azure Fundamentals badge, because the Administrator exam it's pretty tough because of the depth that it goes into. It goes pretty darn deep. Whereas the Azure Fundamentals is intended not even necessarily for technical professionals. The idea is that if you're working with Azure, even in a non-technical standpoint, you may benefit. It looks like there's other fundamentals exams besides Azure, Dynamics, etc. But that would be that. If you're looking at certifying in a vendor-neutral context, CompTIA has a certification called Cloud Plus. I don't know much about it, to be perfectly honest with you. But if I were to go for a vendor-neutral cloud cert, that would be the one I would probably go to, because CompTIA has been around for over 20 years. They've got credibility in the industry, and they put quite a bit of effort into the skills that they pack into their certs. So they tend to be worthwhile to study for and pass in my professional experience.
Next up, when you're in the Azure portal, what is the feature or service that shows the Visio diagram of your services?
Right, that would be the markdown tile that I showed a few minutes ago.
Next up, would it be appropriate to shift the paradigm gradually? For example, on-prem to IaaS, then IaaS to PaaS, then PaaS to SaaS?
Sure, that happens every day in business. Because like I said, although the business may want to taking baby steps into the cloud, it's natural, it seems to me, from a human nature standpoint, that you'll want to stay where you're comfortable. I mean, Azure, any public cloud can be incredibly daunting, intimidating, and scary. What if you get breached? What if you leave a control on when it should be off, or vice versa? So sure, it makes all the sense in the world that you might want to start with infrastructure as a service. And then once you're there and get your sea legs, then start to branch out. That happens every single day in business. And I really give Microsoft huge props for how they handle that. I think I mentioned this last week, but if not, I'm going to mention it right now briefly. That there's all sorts of possibilities, transition possibilities. Like if your web server is currently in a VM, you can just start by deploying the application to App Service and run it side by side for a while. Or your database, you might want to copy an instance of it out into Azure SQL, and gradually, and then you can have them coexist or integrate them, and eventually you're half IaaS, half PaaS, or mostly PaaS. There's lots of easy, gentle transitions to go from one extreme to another in the cloud, absolutely.
Got it. Do you have any tips to find extra material to study for the AZ 103 exam?
For Azure Administrator? Well, heck, I hope you're a Pluralsight subscriber, because we have the AZ 103 skill path right in our product. And that would certainly cover your bases from the theoretical standpoint. And if you're following along with the demos in those computer-based training courses, that would cover your hands-on base. Another option would be Microsoft Learn, microsoft.com/learn. This is free. You sign in with your Microsoft account, and you'll want to go to their paths page, as I'm going here. And they have a path in here. If we go under Roles Administrator, and it looks like there's 350 modules that cover, I would imagine, every exam objective. I haven't gone through every one of these, but those are quality. If you're more of a book learner, you could either, hopefully you're in the Azure Docs across the board. That's an important place to be. This is Microsoft Learn, but you get the idea. It's docs.microsoft.com/Azure. Books are really not a great fit for Azure, to be perfectly honest with you, because once you commit, I know this because I've written an Azure book that currently is under revision because it's being changed. But the AZ-103, there's an exam ref. I was trying to find the page. You can go to the Amazon or the Microsoft Press store. There's the Microsoft Press exam refs that are written to the exam objectives. But again, the issue with those is that once you've printed something on a page, it's fixed forever, or at least until the next edition. And Azure just moves too quickly for that, in my humble opinion.
Got it.
I hope
Thank
that
you.
was helpful.
Definitely, I think so. Our next one, you mentioned that the app service keeps charging money even when it is stopped. Is there any way to avoid this, or just deleting the app? Also cost related. Will it be cheaper than having a VM with our application?
Yeah. Well, I don't want to just make a blanket statement with regard to cost, but you need to consider that when you're using a VM, it's not just the VM resource that you're paying for. If the VM has a public IP address, you're paying for that. If you're using a load balancer, you're paying for that. Depending on whether you're doing premium or standard disk storage, you're paying for that. So there's a lot of para costs besides just the VM itself. And so, yes, it is true that for app service, even if you stop it, you still are paying. However, you've got the ability to resize the app service plan, and you can do that with a virtual machine for that matter. But remember, if we go under scale up, you can change the pricing plan. In fact, once I helped a customer with this who's really cost conscious, which makes sense, and they wondered if we could use, say, the Azure Automation Service and PowerShell, a runbook, to when you're off business hours, to change the pricing tier of the app. And as long as you're not changing it in such a dramatic way that you're not able to do it because you're using features that are only unlocked at a certain level, you do have some wiggle room there. So you could go, for instance, to S3 during business hours and down to S1 during off hours. So that's a creative solution to where you can't stop the billing for the app service, but you can still keep it running. You could use some kind of automation. As I said, a PowerShell runbook and the Azure Automation Service would do the trick to change the pricing tier depending upon your time of day. So consider that.
How deep should an Azure admin know Azure PaaS architecture to be a subject matter expert? What skill sets are required to excel in Azure PaaS?
Yeah, nice question. Sounds like I'm a shill for Microsoft role-based certifications. I'm really not. I'm that kind of a geek. But to tell you the truth, those role-based certifications, Microsoft, what they did is they took their own engineering team members and put them in the same room with subject matter experts. That is, say for Azure Administrator, people who do cloud administration as their job every day. And they put together a job task analysis, and the results of that labor are the skills that are in these badges. So what I want to say is, by you studying and earning, say, the Azure Administrator badge, you are verifying that you're up to date with the real, most practical and used industry skills that go with that job role. So it seems to me, if you're looking to be relevant as quickly as possible, once again, take a look at these role-based certifications. And even if you're not going to take the exam, make sure you understand how to do all of the skills that are reflected in the outline for that exam.
Got it. Thank you. It looks like we have time for one more. How do you get Azure Sandbox access in Microsoft Learn?
Okay. All right. Let me see here. Trying to quickly find a lab. Not every lab does have the sandbox in it. Step one is that you'll need to make sure that you've signed in with your Microsoft account. That's one. Second, you'll find a lab that has sandbox access. I know that the Create Virtual Machine ones do, so let me quickly do search for Create Virtual Machine, create a Windows Virtual Machine in Azure. And let's see here. Exercise, create a Windows virtual machine. So after you've signed in with your Microsoft account, you find a lab that includes the sandbox component, which this one does, and you activate the sandbox. It's going to go through a spin-up process here, and you'll have to review the permissions that are required. So this is saying the organization Microsoft Learn Sandbox is going to sign you in and just read your name, email, and photo if you have one. And if you accept that, you'll be taken into the Azure portal using Microsoft subscription. Now, what's the meta on this? You'll have to read the docs on how long the sandbox access is good for. I think it's a good length of time. I don't think it's like 30 minutes. I think it's hours. And you're limited to a certain number of sandboxes per day, per 24-hour period, but it's a really generous number of sandboxes. So you should be able to get some really quality hands-on experience by using the Microsoft Learn sandboxes. There we go. You've used one of 10 sandboxes today. More sandboxes will be available tomorrow, and it looks like it's an hour. Okay. Well, that's not bad to complete a VM creation exercise.
It looks like we are just about out of time, so we are at that time to say goodbye to everyone. Thank you again, everyone who joined. If you had any questions that we didn't have a chance to answer today, bring them to the next session, which will be next Wednesday. And Tim, thank you as always for teaching us.
You're welcome. Thanks, Alyssa. Thanks, everybody.
Thanks.
See you next week.